An ion is a charged species. Now, this can be individual elements that have lost electrons or gained electrons. But there's also polyatomic ions, so things that look more like molecules. We have a combination of elements, and those combined element sets can gain electrons or lose electrons as well. So we can break the ions down into two subcategories. We have cations, which are positively charged, and they're positively charged because they lost electrons. Remember, electrons are negative, and so if you lose something negative, you lose a negative person from your life, now your life becomes more positive, right? So, it's a little bit counterintuitive, but they become more positive by losing electrons. And an anion is the opposite. So an anion is negatively charged, and an anion comes about because a species gained electrons, gained more of that negativity that we associate with the electrons. And then just to help you remember, we have a little cat and it's positive, right? With its paws, positive. It doesn't really work with my accent, but yeah, just to kind of help you remember. So another thing that I like to tell students, especially because I used to teach high school and students had a hard time remembering the ions. So I would always remind them it's positive to lose and negative to gain. And kind of just kept on repeating that until it's stuck in people's heads. So if you're having trouble with this, remember the electrons are negative, so it's the opposite of what you think. It's positive to lose and negative to gain. Right now at this point, we need to be able to predict the ions formed by each element so that we can work on our electron configurations and our nomenclature. So let's do a couple of examples of that. We'll start with sulfur. So you're going to want to grab your periodic table. Once you have your periodic table, you want to remind yourself of the charges associated with particular groups on the periodic table. So in group 1A, they're going to want to lose one electron. So we have +1 here and +2 here. Remember, the +2 in group 2A is because they have 2 valence electrons that they're going to want to lose. Then you come over to the opposite side of the periodic table, and noble gases are very stable as is, so we're going to put a 0. They don't gain or lose electrons. -1, because the elements in group 7A want to gain 1 electron. We're going to do a -2 right here, and we're going to do a -3 above group 5, because if they gain 3 more electrons, then they'll have the 8, and the 8 is the goal for all the elements. Now, in the middle of the periodic table, it gets a little bit trickier. So some of the charges that you need to know and you need to memorize. We have aluminum. Aluminum has a +3 charge. And then below it, we also have gallium with a +3 charge. But a key to help you remember this is that this is group 3A. So we have 1A, 2A, 3A. So it kind of makes sense that the metals are going to be your losers. The losers are on the left. That your metals in group 3A want to lose 3 electrons. And then zinc does a +2. And so does cadmium below that. And then we have silver with a +1. So the ones that I've marked in here are constant charges, and chemists just know what they are. Now the rest of them in here, we're going to hit upon a couple of examples. There's all levels of confusion in here. So these elements in here can do multiple charges, like copper can do a +1 or a +2. You don't have to memorize that. I'm going to teach you how to figure that out from context information. Helium doesn't acquire a charge because it's a noble gas. So this is going to just stay as is. The other thing I should mention with the last two examples, the 1 is understood. So lithium does a +1, so we'll simply just write a plus. And fluorine does a -1, but we just write a negative.